first we will discuss the Euler's theorem. So by definition, we have this equation. So cosine theta plus j sine theta is equals to the e raised to j theta plus e raised to negative j theta over 2. So, din sila halin. So, this is usually came from the analytic functions. Okay, so natandaan nyo na siya. If, so, complex numbers can be used, no? Instead of real numbers, di ba? Sa itong discussion, I will just take a screenshot. We'll have a discussion. Okay, so for example, we have we left z a complex in the right hand side, no? So we have e raised to z. So this is an analytic function, So familiar ka mo sa Taylor expansion? So when we use the Taylor expansion, so we can have actually e raised to z is just a expansion siya, no? For the series expansion sa ating analytic function. So actually this e raised to z sum lang ni siya sa aton nga cosine theta or cosine z. Okay. So i-ano to siya, cosine z plus sine z. Di ba mo na siya sa aton nga complex functions? So equivalent na siya. So this is in exponential and then this is in trigonometric. Di ba? So if we use this series of extension of the functions sa complex plane natin, so this cosine z using the Taylor expansion, this has a equivalent of a series numbers. So this would be 1 minus z squared over 2 exclamation point. Okay. Then actually this is for the this is in even. Then pag abot sa sign, we have the add. So this is an add. So this is equal naman siya sa 1 or z minus z cube over 1. So this will be z raised to 4 over 4 exclamation point. So mabalanta ni siya later on sa aton yung topic nga series, sa power series, no? Sa Maclaurin kag sa Taylor expansion. Z raised to 5 and then 5 exclamation point. So if we add this one, eto, kung sundon ta ni siya, we can have e raised to z equals to, so i-plus na ning cosine z kag sa sine z. Okay, so this will become 1 plus z raised to 2 over 2 explanation, and then plus z raised to 3 over 3 exclamation, and so on. Okay, so the convergent sums sa aton nga can be taken as definition as extensions of the functions to the complex plane. So mula siya ginatawag natin analytic function. So this one, this e, this cosine, and then this sine. So related sila gyapon. So by theorem number 2 of complex numbers, so how can we get this one? So we can get this equation, the definition of Euler's theorem, if we add and subtract the two equations, this equation and this equation. Okay? So, same man Japan. Okay, so if we add the equation 1 and 2, so the result will be e raised to j theta plus e negative j theta equals to 2 cosine theta. Then getting the cosine theta, so transpose na lang siya. So we can get the value of cosine theta, which is e raised to j theta plus e raised to negative j theta over 2. Okay, so this is your, okay, so therefore we can have this one, this equation. And same process if we subtract equation 2 from equation 1, so we can get this sign. Of course, this is related to Taylor's expansion man kag sa aton nga Maclaurin's expansion. So depende. Okay? So that is for the Euler's theorem. So question guys. Actually, ano nyo lang siya, review nyo lang inyong trigonometric. Inyong trigonometric. Okay? So, this is, klaro na sa Euler's theorem?
Yes, sir.
Okay, so same lang na siya nga process. Okay, so trigonometric functions of complex numbers. So basic man tagapon, start ta sa aton nga cosine kag sine. Okay? So cosine, so ang pagkaiba lang is negative ang sign. So sa sine niya, we have the complex form. So J2 sa denominator. Okay? Then for the tangent, so that is J. So that is review nyo lang inyo nga planar. Okay? Sa aton nga sa aton nga what you call that? Dito. Sa aton nga Cartesian plane, no? So sine, cosine. Okay, so if we have cosine theta, so ano siya? 2 cosine theta, di ba? That is adjacent over hypotenuse. Okay, so we have 2. So take note lang aton nga angle from is in between, no? In between sa aton nga x-plane kag sa aton nga hypotenuse. Okay, so that is adjacent. So x natin is 2. So this is will be 2, di ba? And then ang aton nga angle theta is this one. And then for the e raised to j theta, so sa aton nga dito. This is will be our e raised to j theta at the exponential form plus e raised to j theta, j theta, negative j theta. So review nyo lang inyong SOHCAHTOA. Then you can manipulate this one to get the value of the tangent. So take note lang sa aton nga sign. Okay, so we have the positive and negative. So that is for the trigonometric functions. So of course, this is related man sa aton nga logarithm pag-abot naman sa aton nga inverse trigonometric functions. So later on, we will check the proof, no, sa aton nga inverse trigonometric functions. So from these trigonometric functions, with the use of logarithm, we can evaluate the equivalent function, okay, in terms of the inverse trigonometric functions of complex number. So let's say we have this one. Let's check the example number 1. Let theta is equals to arc sine x. So this will become, obviously, sine theta is equals to x, diba? Okay, ano to siya, i-arc sin to siya, makuha tayong theta. Then, using the trigonometric function, so sin theta, so values ng sin theta is ito, di ba? This one. Ito yung sin theta natin. Euler's theorem. Kag sa trigonometric form niya. So, this will become equal to x. Okay? Then, transpose na lang ni siya. We will become e raised to j theta minus e raised to negative j theta. Ito siya. Then, equals to j2x na siya. Okay? Gin-transpose na ng j2 sa piyak, sa left, sa right side. Okay? So, j2x. Then, what's next? So, multiply both sides by e raised to j theta para makaubra kita sang quadratic equations. Okay? So, then, reduce to quadratic equation form. So, we have the e raised to j theta quantity squared minus 1 equals to j2x e raised to j theta. So, transpose na lang siya. Use the quadratic formula. So, you have your a, b, and c, the value. Okay? Then, dito. What's next here? So, muna ni siya, no? So, we have 4 minus 4x squared. Tama. So, this will become negative j squared. So, that is plan siya kanina, negative j squared. 1, di ba? 1. So, it will become ito. So, minus 4x. So, this will become negative 1. So, times 4. So, that is 4x squared. Then, we have 4 times negative 1 times negative. So, that is positive 4. Okay? So, this is positive 4 minus 4x squared. Okay? Then, over 2. So, how about this one? Paano naging 2 square root of 1 over x squared? So, i-factor to siya, no? So, using the factorial, o i-factor out natin. So, we have 2 square root of 1 minus x squared. Factor natin. Okay. So, I think this is 4. This is square root of 4 times square root of 1 of minus x squared. Siya. Then, you can have these 2 square root of 1 minus x squared. So, this is using the radical rule. Okay. So, we use the radical rule to obtain this one. Okay. Then, proceed with the division. So, divide natin. So, it will become jx na lang mabilin. So, makancel ang 2. Then, plus minus square root of 1 minus x squared. And then, take the natural logarithm on both sides. So, we have the ln of this one sa left side kag sa right side. And then, so ln of e, di ba? So, this is, ano ni siya property sa logarithm? If you can recall. Ano ni siya property? I think this is property number 3. Tama? This is property number 3. Okay, so this is property. So, property is number 3 of logarithm. So, mabilin is j theta. So, actually, yung answer nyo dire is in rectangular form. Okay, so this is in rectangular form. Pero this is in, getting the proof lang sa atong trigonometric functions. So, proof pa lang ni siya, no? So, pila na ni siya? So, this will become ln of x. So 1 over j. So dinhalin ang 1 over j. Transpose, no? So gin-transpose na ni siya ang j diri sa piak. So this will become, or we can say divide both sides, no? Divide both sides by j. So obviously we have the 1 here. So 1 over j ln. Then what's next? After sine, so but 1 over j is negative j, di ba? So ano lang siya, inverse. And theta is arc sine x. Eh, di ba naglet kita diri kagina. Therefore, arc sine x now, so arc sine x, or arc sine x is equals to, ilan na ni siya? So negative j, di ba? So we have negative j
Yes, sir.
ln of ito x plus minus square root of 1 minus x squared. So man ni siya aton nga proof. So if we check the arc sine, so the same, diba? So that is j ln of jx plus minus square root of 1 minus x squared. Okay, so I think correct, no? Correct ang value natin. This one. So this is in evaluation lang kung paano nakuha ang aton nga value sa inverse trigonometric function. Okay, so same process lang. Pag-abot sa iban, no? Kung pangitaan ta naman ang values ng arc cosine of x. So cross multiply, then reduce to quadratic equation. Then using the quadratic formula, then factor out. Then use the radical rule, this one. And then take the natural logarithm on both sides. Okay. I think this is kaya nyo naman yan, no? Ano naman siya, self-explanatory.
Yes, sir.
Din pa ang wala nyo na-gets masyado. Wala pa man ta, no? Example, gid nga, no? Or this is the proof lang. Same lang siya. Cross multiply, divide, then take the square root. Kuri ang process, ari naman di sa gilid eh. The step-by-step process, explanation, ari na di sa gilid. Already included that. Quadratic formula. Radical rule. Same lang process. Factor out. Then take the natural logarithm. So how about this one sa hyperbolic? I think kabalo mo kasi magamit, no? Sa inyo calcu. Magamit sa hyperbole. So wala na taga-convert sa degrees ha. Sa hyperbole. I think we can have an example. I will check. Example kita. Example. So for this example, I think you should review your trigonometric identities. Okay, especially the addition formula, no? Atong trigonometric identities. The algebra lang ni siya. May mga JJ lang galing. Cosine 0.573 plus J 0.783. Okay, so this is from trigonometric identities now. So here we apply the identities. So cosine of x plus y. So cosine of x, cosine of y minus sin x sin y. Tama. Amo siyang sa addition formula sa trigonometric identities naton. Okay, then apply. So substitute lang ang given. So we have the x naton, the real part ni siya ha. So that is 0.573. But take note that this is in angle. Okay. So 0.573. So this is in radians form. So convert into degrees. Ito. So that is cosine 0.573 cosine of j 0.783. So here we apply the hyperbolic function na. Okay? So cosine of jx. So pila equivalent sila sa cosine jx. So if we get the relations between the hyperbolic and trigonometric functions, so cosine jx is just equals to cosine hyperbole of x, cos hx. Okay? So in this case, we use the cosine h 0.783 here. Dito. Ito siya. Yan. Then, for the cosine 32.83, so we convert the radians form. Ito. Hindi nyo tawag siya na, i-convert nyo danay sa degrees. Naka-rectangular form kita diyan, rectangular form aton nga angle. So you need to get the angle in degrees, and then for the complex component, use the relations of the hyperbole and trigonometric identities. So that is cosine h 0.783. Then same value, so that is sine. So convert man. So that is sine 32.83. And then for the sine j, so this is in hyperbole naman. So convert nyo siya. So that is sine h of 0.783. Hindi lang ka maglasa. Okay, then proceed the computation. So that is cosine 32. Ito siya. Then cosine h 0.783. So I think this is